Sometimes one-step equations involve fractions. We apply the same concepts that we have for any other one-step equation. We ask what's happening to the variable, we look at the inverse operation that will give us our identity to cancel out any values around the variable, and then we evaluate. The only difference when there's fractions is that you have to use your fraction skills when you evaluate your final answer. Otherwise, equations with fractions are not at all different than equations without fractions. Just like one-step equations that use multiplication and division are not handled any differently than equations that have addition or subtraction, other than the fact that you're using different inverse operations. So let's review. Let's go back to the basics a little bit and talk about multiplying fractions. To multiply fractions, we do not need common denominators. That's an easy mistake a lot of students make. Multiply the numerator straight across. This is your new numerator. 8 times 6 gives me 48. Multiply the denominator straight across. This product is your new denominator. 9 times 12 is 108. Simplify. Multiplying fractions is one of the simplest skills. Last step though, we need to simplify. So I take the factors of 48. 48 divided by 1 is 48. 48 divided by 2 is 24. 48 divided by 3 is 16. Divided by 4 is 12. Divided by 5 is a decimal. Divided by 6 is 8. Divided by 7 is a decimal. 8's the next number I check, so there's my end of my factor list. I'm going to do the same thing with 108. 1 times 108. 108 divided by 2 gives me 54. 108 divided by 3 gives me 36. Divided by 4 gives me 27. Divided by 5 gives me a 0. Divided by 6 gives me 18. 7 is a decimal. 8 is a decimal. 9 gives me 12. Divide by 10, decimal. 11, decimal. 12 is the last factor that I can pick. This is the double mountain method. I could just find the factors of one value, usually the smaller, and then take turns. 108 divided by 48, 108 divided by 24, 108 divided by 16. So take turns dividing each of your factors of the smaller value and divide it from the bigger value. The first time you get a whole number, that's your greatest common factor. With the double mountain method, we list both sets of factors and find the value that's the biggest in both. I'm going to divide top and bottom by 12. That's going to give me 4/9 as a final answer. Let's try this next one together. I multiply my numerator 6 times -2. Remember, if there's a fraction and a negative out front, I like to apply the negative to the numerator. That way it has a place. 6 times -2 is -12. 5 times 8 is 40. That way I also don't put the negative in two different places. I can simplify, so I'm going to find my factors of 12 and my factors of 40. The biggest number in both lists is 4, so I divide top and bottom by 4 to get -3/10. On your own, try multiplying those two fractions together. When we divide fractions, we're really just multiplying, but we have to turn the problem into multiplication first. Remember this mantra: keep it, change it, flip it, multiply it. A lot of students just remember keep it, change it, flip it, and they don't remember to finalize the answer. Keep it. We keep the lead fraction the same. So if we have 2/7 divided by 3/5, 2/7 is going to remain the same. I change it. I change from division to multiplication. And then I flip it. I'm going to flip the second fraction or take its reciprocal. So I'm going to invert it and flip it upside down. Now I just multiply. 2 times 5 is 10, 7 times 3 is 21, and that's already simplified. Let's try this example here. -4/7 divided by 2/3. Keep it. I'm going to keep -4/7. Remember, put the negative in the numerator. That way you know exactly where it goes and how that negative is going to affect the problem. Change it to multiplication. Flip it. The reciprocal of 2/3 is 3/2. Now we just multiply it. -4 times +3 gives me -12. 7 times 2 gives me 14. And then I can just simplify from there. Take my factors for each. Find the number that is the biggest in both of these lists. It has to be a number that's common to both. Divide top and bottom by 2, I get negative 6/7. On your own, try the last problem. Remember, keep it, change it, flip it, and then multiply it. Give this problem a try. We have the equation 1/2 x equals 8. It's perfectly balanced on our balance. What value could equal x? How do you find this value? Try the problem and then explain in your own words how you solved it. Inverse operations act like a zipper. It's all the same parts, they just go in different directions. One gets put together, the opposite direction gets taken apart. This is just like using the order of operations to help us understand equations. We ask ourselves two questions. What's happening to the variable? That's if we had put together this equation using the order of operations. I see x divided by 2/3 equals 1/4. We clearly divided by 2/3. So that's what's happening to the variable. How do I undo this operation? I need to multiply by 2/3 on both sides. I apply it to both sides of my equation. When I multiply and divide 2/3 against the same value, I'm going to get that identity of 1. That cancels out and leaves me just x by itself when I evaluate. X equals, and then I multiply my fractions. 1/4 times 2/3 is going to give me 2/12. Now I can simplify if I need to, divide top and bottom by 2. I know they're both even, so I'm going to end up with 1/6. If I were to plug this value back in, 1/6 divided by 2/3 would equal 1/4. That's how we check our problems. Here I have 1/2 equals negative 5/12 times x. Ask yourself, what's happening to my variable? I'm multiplying by negative 5/12. To undo that operation, I need to divide both sides by negative 5/12. Notice I state the value and the operation. It's not just dividing by 5/12. I'm dividing by negative 5/12. It's going to cancel on the right, leaving me with just x by itself. Now I need to divide 1/2 divided by negative 5/12. Keep it, change it, flip it. Keep 1/2, turn division to multiplication, take the reciprocal of negative 5/2, so flip it upside down, and then I'm just going to multiply now. 1 times 12 is 12, 2 times negative 5 is negative 10, and then I can simplify from there. In this case, I turned it into a mixed number for my final answer. If the problem starts as a fraction, it ends as a fraction. Here I have 3x over 15. This may not look like an equation that involves fractions, but it is. This is really the same as saying 3/15 times x. So I'm multiplying by 3/15. To undo that, I divide by 3/15. And I know that I'm multiplying by 3/15 because if I look at that problem, x is directly next to 3, so it's 3 times x. The 15 is dividing, or being divided from 3x. So I have 3 being multiplied, 15 being divided, which gives me 3/15 as a fraction. I'm going to divide both sides by 3/15. When I do that, it's going to cancel out 3/15, leaving with just x on the left. Now I need to keep it, change it, flip it. So instead of 2/9 divided by 3/15, I need to make it 2/9 times the reciprocal of 3/15, which is 15 over 3. 2 times 15 is 30. 9 times 3 is 27. I'm going to turn that into a mixed number. 27 goes into 30 one time with 3 left over. 3/27 simplifies down to 1 1/9 altogether. On your own, try the last two problems. Follow the same steps you would to solve any equation. When you multiply fractions, multiply straight across. When you divide fractions, you need to turn it into multiplication following our mantra. Keep it, change it, flip it, multiply it. There is a small shortcut that works with problems like this, and it works even better when we get to two-step equations with fractions. Find the lowest common multiple of the denominators of all fractions in the equation. So I have 2/5 x equals 3/8. So I'm going to find the lowest common multiple. So I'm going to list out my multiples In this case, the lowest common multiple, the smallest value that they both multiply into, is 40. I'm going to multiply the whole equation by this LCM, this lowest common multiple. So I'm going to put big parentheses around the whole thing. I need to multiply each term. Think back to when we talked about algebraic expressions and combining like terms. Like terms are separated usually by addition, subtraction, or any term separated by that. They're brought together using multiplication, division. So here I have 2/5 x, that's one term. 3/8, that's one term. 40 times 2/5. I could go into turning 40 into a fraction as 40 over 1, and then multiplying the fractions together, or look at the equation as a series of operations. 40 times 2 is 80. 80 divided by 5 gives me 16, 16x. 40 times 3 is 120. 120 divided by 8 gives me 15. Now it's turned into a one-step equation. I'm just going to solve this final one-step equation. What's happening to my variable? I'm multiplying by 16. To undo that operation, I use its inverse. So I'm going to divide by 16 on both sides. If the equation starts with fractions, it needs to end with fractions. So x equals 15/16. Remember, if you substituted that value in, 2/5 times, instead of x, 2/5 times 15 over 16 should simplify down to 3/8.